ls minus lh, CPU info, it is going to show the file size as 0. Okay, so this itself says it is a pseudo file system, and it is all been created virtually in the kernel space. Okay, so similarly we should also find this sys folder. Okay, so this is the sysfs which they are referring. Although they mention as sysfs, the folder name is sys. So same thing happens in the sys folder. Most probably you will find this 0 files and stuff. So in the sys folder, if you go to the devices, if I remember correctly, if you go to the devices, devices system, because I did this quite long back, I am not sure, it's not devices. So let's go to bus and GPIO. Yes, it's in bus. So you can see there it is in sys bus GPIO. So in this we can instantiate a GPIO pin, and we can initialize, and then it will get instantiated, and then we can start using that. Okay, so if you go here, and we can go to devices, and we can go to drivers. No, GPIO, I think I am still not sure, because it is not this. Drivers auto probe, I am not sure. No, it is not this actually. Yes, it is not here. I think I need to go back, and it should be in this class directory. Yes, there is also another GPIO there. I'm sorry, I got confused. So go inside this GPIO, and you should able to find this export file. Okay, so cat, let's not do a cat, ls minus lh, and you can see there the file have some contents, but please bear in mind this is also a pseudo file system. There is nothing over here this is not anything it is there on the SD card. Okay, so what we should do is to instantiate, we can do earlier before that sudo and echo 11, because I connected to that pin 11. I can show you here Raspberry Pi GPIO pin out. So let's go to images. Yep, something like this. So I have connected to this pin, okay, which is this side. Okay, so which is GPIO 11. Yeah, you can see there GPIO 11, and then right next to it I can tap the ground as well. So I can tap it here or here or here, anywhere. Okay, so of course if I need to power on this LED all the time, then I can tap over here 5 volts as well. Okay, so that's what is the topology or the circuit I connected. So what we do is we can set this thing, and it will instantiate. Okay, so once it is done, you can do ls minus lh, ls minus l lh, I'm sorry, just ls command. You can see there is this folder which is created, or a directory which is created called GPIO 11, and if you notice, there is no such directory over here before that. So the driver have initialized. Once again, sometime in the future I may take a video on the driver source as well. Okay, but as of now I just want to give an overview. The whole learning curve is about the kernel interfaces and a sort of raw access with your Raspberry Pi without any other programming language. Because if you do this, all you can do is you can start writing a direct thing in C, or any language of your choice. Okay, via system APIs. Okay, yep. So you can see there you have all this files ls minus lh, and you should be able to find this thing direction. So the direction tells it is it's an outgoing or incoming. Okay, so what we can do is we can set echo out direction, which means it is an outgoing GPIO pin, and then we can set the value. So you can see there the value is there, and cat value it is having the value as 0, which means it is disabled. Okay, so echo 1 and we redirect to value, and you can see there immediately the LED is turned on. Okay, so hopefully you should be able to see that in the camera. So let me zoom a bit, you should be able to see this. Okay, so you can see there, yeah, this is the red LED, and of course I can connect this to other pin, and in the middle one, see, this is the green one, and this side is the blue one. Okay, so let me connect it back, because it is just one more pin over this side is the ground, so I don't want to short circuit. Okay, see, be careful when you are new to Raspberry Pi. I'm saying even I have students who are more than 35 years, but when you have any kit or something like that, just be careful. If you are new to electronics, or make sure you don't fiddle around, and make sure you connect some type of protection in the middle of these jumper wires, unlike me, so that if you short circuit or something, it is handled properly. Okay, either you put a fuse or just do something about it. Okay, since I'm doing it from class 4, okay, I was doing hobby electronics and stuff, so it is nothing new to me. So I do have I do make sure that I don't short circuit. Okay, I'm just saying. So when you do like this in the live circuit, make sure you don't make any goof ups. Okay, so you can see there it's value 1 and it is glowing green now, and if I set it to 0, it should disable. So with this it is as you see here, it is quite simple. With this it is quite simple. You can write any language of your choice. You don't need any more those APIs what you seen in the past. Okay, see, as a kernel developer, this is what it gives a great how to say, it gives a great powerful interfaces. I can explore, and then I can get to the source. I don't need to rely on the libraries and remember what is that command or what is that API I need to use, and in which language is which corresponding header file I need to include, or libraries I need to include. I don't need to fiddle around. See, it gives a complete raw access, and it is more powerful way to do this way. So now you can write any C code. See what it is preventing you. You can go to this and mkdir test pi, and we go to this folder, and we can write a small C code. Okay, so led c.c, and we can just include. See, we don't need to do standard. We don't. Let me come out of the root access mkdir. Let me go to this home folder, mkdir test pi cd test pi. I don't want to do with root access. Let's see if it works as a normal user. Okay, vim led underscore c.c, and here if you notice, insert here, if you notice, I don't need to include any special those LED libraries, GPIO libraries, I'm sorry. Okay, so include stdio.h. okay, only that is enough. If any other APIs, maybe if any other things if I do, then I can do string.h and stuff like that. See, void main, and I can just do this, and I can write a small infinite while loop. Okay, and in this while loop you can just do this system, and you can set the LEDs over here, and you can put a sleep of 1. Okay, and for the sleep command you should include some you should include unistd or some header files. Okay, so man3 sleep. Yeah, you can see unistd.h. so let's include that. If sometimes in your system, if man3 doesn't work, try with man2, man4 and stuff like that. Okay, it depends on which level it is registered. Okay, include unistd, sorry, in the braces, unistd.h. okay, just do that alone, you don't need anything else. And we need to find out what is this path is. Okay, see, sys class GPIO, and then that folder name. Okay, so insert it over here, this thing. Okay, insert it over here, and of course you can have this in variables, or you can have a custom buffer and stuff like that, or maybe hash defines and stuff like that. You can do anything you want. Okay, so you can do this value, and you can do that echo over here. Okay, echo 1, this is to turn on, and then you can just copy paste the same and set this value to the 0 over here. Okay, oh, I'm sorry, undo, yes, insert, and then let me try that. GPIO value echo 1, I'm sorry, echo 0, so it will turn off, and then we can add one more sleep here so that it is blinking alternatively. Okay, so sleep of 1, so it is going to turn on, sleep for 1 second, and it is going to turn off, sleep for 1 second, so it is going to alternate between these two states. Okay, so if we do a quick compile, gcc -o led_c led_c.c. Yes, so system command needs some header file, so we can check man system, it's stdlib, so we just include that as well. Okay, see, although I'm including anyway a couple of header files, these are generic header files. Okay, lib.c, lib.h. okay, so these are generic header files. This is nothing specific about those GPIO libraries. Okay, so once we are done, you can see there we can compile, and we don't need to include any libraries as well. So if you do with pthreads, you do lpthread. If you do some third-party library like MySQL APIs and stuff like that, you need to do that. Okay, see, when you compile, you do -l and something you need to do. But here we are not including any special libraries. Okay, so you don't need to do anything. See, compilation is over, and we got our binary. We can run this file. Okay. You can see there it's running, and looks like it is not accepting, so the LED is not flashing, which means it needs a root access. Okay, so we can do sudo, and then we can try that in this way. Still the LED is not flashing. Okay, which means something is not right. Okay, let's just debug what it is over there. Okay, so cat led.c.c. okay, let's just debug this and figure out if this command, as you copy paste, it works. Okay, yeah, I just did that, it's not working, so let me just debug. Okay, sudo oh yeah, it is missing that redirection. Okay, so yes, it's just a typo error, so we go to this vim and then we include this redirect, hence it is not working. Okay, so you can see there we can insert this redirect, and then we recompile. Okay, and then we can run it without sudo. Let's see. Yeah, you can see there without sudo it is just working fine, and it is blinking, and it is not displaying anything on the screen because it's a echo to that file rather than anything on the screen. Okay, so echo value to that file, and so it is you can see there it is just blinking. Okay, and more interestingly, we can tap like this couple of more bunch of wires. See, you can see there it is blinking in green, and if I change this lead and connect it to this guy, it's going to blink in red. You can see there. Okay, yeah, so hope you can see in the camera. Okay, yes, so let me put back to the screen. Yeah, because it's little bit brighter than the red. Okay, so yes, so this way you can access, you can do a raw access and not just C code, how quickly you can convert it to a PHP script. See, when I did a cancel, see this it is glowing in green, and it stays in the same color. To avoid that, of course, you can handle signals and stuff like that. Of course, you can handle module or exit API. You do sig kill or something. Of course, when you kill this application, you can handle a signal, and then there gracefully you can turn off the LED before closing the tab and coming out. Okay, so of course you can do that. Okay, but what we do is we can also quickly port this to any language of our choice. Okay, so we can do this cp led.c to led underscore php.php. So we can do a quick edit of this file, okay, and we can convert this to a PHP code.